right, so with 1.2 vertical and horizontal stretches, remember from yesterday that we talked about a translation, and a translation was your H and your K, which moves the graph left and right, or moves the graph up and down. Then we talked about a reflection, and a reflection flips the graph, again, either left and right, or up and down. Remember that if a point is on the line of reflection, then when you flip it, it doesn't actually move. So we call that an invariant point, if it hasn't moved. Now today, this is the trickier one, stretches. Stretches actually change the shape of the graph. They're going to make it either taller or shorter, or wider or narrower from your original shape. You can also have both. It could get taller and wider, or shorter and wider, or whatever. So there can be a combination of those as well. So this is important. A stretch is a transformation in which the distance of each x-coordinate or y-coordinate is multiplied by a scale factor. So when we talk about stretches, we're talking about multiplying. When we were talking about translation, so H and K, we were talking about adding or subtracting. So scale factors between 0 and 1 move the point closer to the line of reflection, where scale factors greater than 1 move the point farther away. That should make sense. If you multiply by a big number, your number gets bigger. If you multiply by a small number, like a decimal, like half, it gets smaller. Okay, so that part should make sense. So if you have y equals f of x and you multiply by a constant a, which basically means you put an a in front of the f of x, that's going to be a vertical stretch. And remember, that's because f of x is equal to y. So really, this f of x means y. So if I multiply it by an a in front, all your y values are going to be multiplied by that a. So if a is big, it's going to stretch taller. If a is small, meaning between 0 and 1, it's going to squish shorter. If a is negative, then it's also reflected. So you can get taller and flip it upside down if the a value is negative. Here we're given the graph of f of x. So the red graph here is f of x. We are going to sketch the graph of g of x and state the domain and range. We didn't do as much of the domain and range yesterday, so I really want to make sure we're good with that today. So let's try the first one. We're going to start by just making our table of values with our original function. So the original function here, the first point is at -6 and +4. The second point is at -2 and 0. So what we're going to do here for part A, again, we're multiplying it by 2. So when we multiply all the y values by 2, the 4 becomes an 8. 0, 0, 2, 4, 0, 0, and 4 times 2 is 8. Then we can plot these points. I'm going to use a different color for that onto our grid. So -6 is now at 8. 2 is at 0. 0 is now going to be at 4. 2 is at 0. And +6 is going to be up at 8. So when we connect the dots, your graph is going to look twice as tall. I'm going to show domain and range of the original function in red here because it's a red graph. So the domain of the red graph goes all the way from -6 to +6, because that's my x-axis values. So I would say that -6 is the smallest, +6 is the biggest, and all the x's are in between -6 and +6. And then you open your signs toward the bigger value. So the domain is from -6 to +6. The range of the original goes from 0 up to +4. So 0 is the smallest, +4 is the biggest, and all the y's are in between. And then we make our signs, again, to point toward the bigger value. So again, this means that all of my y's are in between 0 and 4. Now, what do you notice about the domain of the green graph? So we didn't change the x's, which means our domain is going to stay the same, but we did multiply the y's by 2. So now the range is going to go all the way from 0 to 8. And it's going to be twice as big as before because all of our y values have been multiplied by 2. So for our next one, we're going to try the exact same thing here, except this time we're making it half as tall. So all your y values are going to be half as big as they used to be. And your graph is actually going to look half as tall as it used to look. We're also going to do the domain and the range for these two graphs. Good, so you can check your answers here on the board, and then we're going to move on to the final one. Please try this one again. And for this one, we're going to be multiplying all of our y values by -2. So try to predict what it should look like. Okay, the negative will flip it, and the 2 will make it twice as tall. So when the input of a function is multiplied by a non-zero constant b, the result is the b inside by the x. So now we're adding in a b value. The b value is the horizontal stretch, but it's by a factor of 1 over b. Note that if b is less than 0, so that means if b is negative, it's also flipped left and right. So let's go through the same process here. If we make our original table of values, we plug in -4 with +4, -2 is with 0, 0 is with 2, again 2 is with 0, and 4 is with +4. So we make our original table of values. Now, again, I'm going to switch colors. Our x values are actually going to be divided by the b term. So for this one, it's f of 2x. So the b value is 2. So I'm actually going to divide all my x's by 2. So -4 becomes -2. -2 becomes -1. 0 is still 0. 2 becomes 1. And 4 becomes 2. Now this time my y values have not changed. Because I haven't done anything to the y's, I've only done something to the x's. When we go to plot these, again, now my new point is at -2 and 4. -1 and 0. 0 and 2. 1 and 0. And 2 and 4. So when you look at this, my new graph is actually half as wide. So when your b value is 2, it actually gets half as wide. So it's the opposite as it seems like it should be. So now let's compare the domain of the new graph. The new graph only goes from -2 to +2. So -2 is less than or equal to x is less than or equal to 2. So notice that the domain is also only half as large as it used to be. The range in this case hasn't changed. It still goes from 0 to 4. So notice that this time we've only changed our x's, so only the domain has changed. So we're going to start again by writing out your original table of values. So once you make all of your x values 2 times bigger, again, that's because it's 1 over your b value. So if your b value is 1/2, that's actually like multiplying by 2. Let's come up with the domain and range then of our new graph. So in this question, we're saying that we transform your original graph with a vertical reflection. Write the equation of the transform graph. So this is very important. And it also shouldn't say reflection. That would be a typo. It would be a vertical stretch. Because what does reflection mean? Flip. Okay? This graph was not flipped up and down. It's a vertical stretch. So we want to take a look at a point right here. Okay, we know that the original absolute value function would go through, looks like here it's 2 and 2. That's because when you absolute value something, you get the same number, it's just that it's positive. But now, if I follow that point 2 and 2 has now been moved to 2 and 6. So what did I multiply my y value by to get it to go from 2 up to 6? What did I multiply by? 3, right. So that means that the a value is 3. So the equation that would be described is that g of x equals 3 times f of x. So to show the mapping here, the x and the y value, the x wouldn't have changed, but the y value would get 3 times taller. So in mapping, it would be x, comma, 3y to represent this. So again, we're just comparing the transformation to the mapping. The only new one here that you really haven't seen before is b. Now when we map this, it's going to be x over b plus h, and a times y plus k. finally for today, it's just really important to keep in mind that a vertical stretch results when the graph is stretched or squished in the up and down direction, whereas horizontal is stretched or squished in the left and right direction. And note that the horizontal stretch seems opposite of what it should be. So B is backwards. We're then just going to move on to the textbook questions. It'd be a great idea to read the key ideas on page 27 before starting these questions.